Hey there, ever looked up at the night sky and wondered how stars are born, live their lives and, yep, even die? Well, get ready, because I'm about to take you on a wild ride through the life cycle of a star, from its dramatic birth to its cosmic farewell. Let's rewind to where it all begins, the cosmic womb. Picture this, a massive, chilly cloud drifting through space. This is a nebula, filled with gas and dust. Now, something stirs. A nearby supernova explodes, or maybe a passing galaxy tugs at the cloud. Suddenly, the nebula starts to collapse in on itself, squeezing tighter and tighter under the force of gravity. The clump of gas in the center heats up, spinning faster and flattening into a disk. This hot core is called a protostar. It's not a star, not yet. It's still just heating up from gravity, not nuclear fusion. But then, bam! When that core hits a fiery 15 million degrees Celsius, nuclear fusion ignites. Hydrogen atoms smash together, fusing into helium and releasing a monster wave of energy. This energy pushes outward, perfectly balancing the crushing force of gravity. That's the magic moment. A true star is born. It enters the main sequence stage, where it'll spend about 90% of its life, just like our sun is doing right now. But stars can't live forever. What happens next depends on one thing: their mass. Let's split them into two paths. Path 1, low and medium mass stars, like our sun. These stars swell up into red giants when they run out of hydrogen in their cores. Gravity squeezes the core, heating it until it starts fusing helium. Meanwhile, the outer layers puff out, turning the star a deep red. One day, our sun will become so huge that it could engulf Mercury, Venus, and probably Earth. After a while, the core gets hot enough to fuse helium into carbon and oxygen. The star pulsates, shedding its outer layers into space, a glowing cloud called a planetary nebula. What's left behind? A white dwarf, impossibly dense, about the size of Earth, but packed with the sun's mass. It cools slowly over billions of years, eventually becoming a cold, dark, black dwarf. Now, Path 2. High-mass stars. Think stars at least 8 times heavier than our sun. These giants live fast and die young. They balloon into red supergiants and start fusing heavier and heavier elements, building up layers like an onion. But when the core fills up with iron, nuclear fusion stops providing energy. Gravity wins, and the core collapses in an instant. The outer layers blast outward in a colossal supernova. This explosion is so powerful it creates elements like gold and uranium, flinging them across the galaxy. What about the core? If it's heavy enough, it becomes a black hole. Gravity's so intense, not even light can escape. If it's lighter, it turns into a neutron star, a city-sized ball with unimaginable density. Here's the coolest part. The stuff blown out by dying stars mixes into new nebulae, seeding the next generation of stars and planets. So every atom in your body? Yeah, it was forged in the heart of a star. Want to dive deeper? Check out our website for study notes, assessments, and video lessons. Follow WUNA Educational Services everywhere: YouTube, Facebook, Instagram, TikTok, X, and Telegram. If you're interested in our services, call us at +25675046370 or +25678846370. Thanks for joining me on this cosmic journey. Until next time, keep looking up.